Hello, good morning, everybody, and welcome to Pankaj's Echelon Tutorials. Now, in this today's session, we are going to start with IGCSE Physics, and very first chapter in IGCSE Physics is something called units and measurements. Okay, now this is something that I'm going to. I have already prepared my notes. Okay, and I'm going to explain you those notes in the form of this lecture. Okay, so I'll take you to the screen so that you can see my notes, and I can start explaining you those notes, right? So I'll take you to the screen now, and here you are on the screen. So I hope you must be uh, looking at the screen now, and as the title mentions, okay, this is IGCSE Physics, and this is for the 9th and 10th grade. So normally in the 9th grade, they start with this very first chapter, right? And the name of the chapter is units and making measurements, right? Now see, I don't stick to a particular book. Okay, so I'm my notes are very general. Okay, and the question answers and the worksheets and all that I will be providing you to you. Okay, time to time. Those will be based on different textbooks and different grades. Okay, like if you are in 9th grade, it will be related to 9th grade. If you are in 10th, it will be related to 10th grade, that way. Okay. So now it's a very formal introduction. It's just the concepts that I'm going to introduce to you all. Okay. So getting started with that, uh, fine. So the chapter one, that is units and making measurements. Okay. Now, in this chapter, you are going to learn how to measure these three dimensions, that is length, volume, and the time. Okay, you are going to learn length, volume, and the time. That's all. Okay. Yeah. 1 second. Okay. Okay. So I think you can see the palm. Okay, and this palm will indicate my cursor. Okay, so you'll understand where I am on the screen. So measurement of length, volume, and time. In this first chapter, we are going to deal with that only. Okay. Now, length can be measured, it can be measured by a ruler. It can be measured by a vernier calipers. It can be measured by a micrometer screw gauge also. Okay. So there are different ways of, I'll go back to the pen only. Okay. Right. I think I have that thing. 1 second. Mm, no, don't have that option right now. Okay. So you'll be learning how to measure the length, volume, and the time. Okay, so length can be measured using a ruler, vernier caliper, micrometer, screw gauge. Okay, and these are for the smaller lengths, right? For the bigger length, bigger length means the distance. Okay, bigger distances. That is, for example, the distance between the sun and the moon, or the distance between the earth and the sun. These are very large distances. Okay, so these distances can be measured by some indirect methods. Okay, now this we are not going to deal in this particular video. Okay, indirect methods for measuring big distances, but this is a part of this chapter only. We'll be coming to that later. So in today's lecture, we are going to concentrate more on only one thing, and that is smaller lengths. Okay, and smaller lengths can be measured accurately using this vernier caliper and micrometer screw gauge. So these are the two instruments that we are going to study very much in detail. So coming to the very first one, that is the vernier calipers, right? Now vernier calipers is an instrument which I have shown you the diagram over here. Okay, now this is the diagram of a vernier caliper, how it looks. So this is a vernier caliper which can measure, number one, the length of certain objects. So whatever length you want to measure of an object, that you have to place between these two jaws. Okay, and you can measure the length. You can also measure the external as well as the internal diameters. Okay, so if you have a rings type of object, okay, a structure of the object is such that it is a ring. So ring has an outer diameter as well as inner diameter, right? So both this outer and inner diameter you can measure using a vernier caliper. And the third thing that you can measure is something called the depth of the container. Okay, suppose you have a beaker, and in that beaker you have suppose water level. Okay, you want to measure what is the depth of the water level, so you can always measure that depth also using this vernier caliper. Okay, so these are small units, small measurements, small length which you can measure. So you can measure length, you can measure the diameter, you can measure the depth of certain objects, right? Now there is something called least count of an instrument. Okay, so every measuring instrument, has certain least count. Least count is what? Least count is the least uh, measurement, okay, that instrument can take, okay, accurately. So for example, the least count of these vernier calipers, most of the vernier caliper that we happen to see in our day-to-day life is having a least count of 0.1 millimeter, or you can say 0.01 centimeter. Say 0.1 millimeter, 0.01 centimeter are both same length, right? Only the units are different. Now this conversion of units also we are going to study in this chapter, okay? How to convert the the unit from millimeter to centimeter, from centimeter to meter, from meter to kilometer, etc. Okay, so all this conversion, of one unit to another unit, that also we are going to study in this particular chapter. Okay, so the least count of a vernier caliper, as I told you, is normally 0.1 millimeter. Okay, I mean to say that there are certain other types of vernier calipers also, for which the least count may be different. It may be not 0.1 millimeter, it will be 0.01 millimeter or 0.001 millimeter. Okay, so depending upon the accuracy to which you want to measure certain length, you can use different vernier calipers. So vernier calipers may differ from one to other in the way that the least count will be different. Okay, otherwise all the mechanism and all that is same. So I hope you must have understood what is a vernier caliper. Okay, and just to make you you know make you have a feeling of it, now this is a vernier caliper. You can see this. Okay, I'll show you on the full screen. Okay, yeah, so this is something called a vernier caliper. You can see on the screen, right? This is a vernier caliper. These are the jaws. Okay, now when I open it, when you want to mount some object and take the reading, show you one second. Yeah, suppose you want to take the reading. Okay, you have to open the jaw, you have to keep that particular object between these two jaws. This is for measuring the external diameter. These jaws can be used for measuring the internal diameter. And this particular stem, this can be used for measuring the depth. You have to insert it in the container, okay, in the beaker in which there is some water. So up to that water level, you have to keep this particular stem, and this will give you the depth of the water level in the beaker. So this is the vernier caliper, just to give you a feeling of how a vernier caliper actually looks. Okay, so this is it, right? Got it? Okay. Now coming back to our this thing, uh, notes. Okay. So that was regarding your vernier caliper, how it looks like. Now let us go ahead and try to understand the different parts of a vernier calipers, right? Okay. So here, uh, okay. Now we are at this stage, that is the different parts of a vernier caliper. So as I showed you the vernier caliper, okay, this is the diagram of a vernier caliper. Now number one is something called external jaws. Okay, number one is external jaws. So this is that pair of external jaws. Okay, this one and two. These are the two external jaws, right? Now why these external jaws are used? So it is used for measuring the outer diameter. Okay, it is used for measuring the outer diameter. So that is one pair of external jaws. On the top you can see number two, that is internal jaws. These are a pair of internal jaws. So can you see, second is internal jaws. Now internal jaws is used for measuring internal diameter. So if you want to measure the internal diameter of a ring, you have to place these two jaws in the inside of a ring so that you get the internal diameter of the ring. So this is that second part. Then the third part is the main scale. Now this is something which is known as the main scale. Can you see this third one? Here it is shown. This is the main scale, right? This is your main scale. Now main scale is a normal scale that you happen to see in your compass boxes. Okay, so you have a centimeter calibration on one side, on the other side you have inch calibration. Okay, so normally we take a centimeter scale because the vernier caliper, this is the vernier caliper, number 4 is a vernier scale. Sorry, not vernier caliper, vernier scale. So vernier scale can slide either on the centimeter side or it can slide on the inch side. So if it is sliding on the centimeter side, you will get the readings in either centimeter or millimeter. If it is made to slide on the inch side, you'll get the readings in inches. Okay, so not a big deal, but as I told you, the main scale will have both centimeter and inches, but normally we take readings in centimeter. So this is that main scale, right? Okay, so main scale will help you in taking the main scale readings. Okay, and in main scale it is in centimeters and inches. The calibration is in centimeter and inches, and the smallest division is 1 millimeter. So on the main scale in the vernier caliper, you will see that the smallest division, the visible, the marked smallest division is 1 millimeter, or you can say 0.1 centimeter. Okay, so that is about this main scale, and this main scale you take a main scale reading. Okay, whatever reading you take on the main scale is known as main scale reading, right? That was part number 3. Then part number 4 is something called vernier scale. Now can you see this particular is a vernier scale, this one, right? This is your vernier scale, this one, right? This is a vernier scale. Now what is a vernier scale? It has certain divisions on it. Okay, now this particular vernier scale, I think it is having more number of divisions. Let me just zoom in and see. Okay, 1 2 3 4 5 6 1 0 1 2 3 4 5 6 7 8 9 and 10. This is having 10 divisions. Can you see? See, this is the 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9 and 10. So there are 10 divisions on the vernier scale. See, in between 0 and 1 also, I think they have given some markings, but ignore those markings. That is only for the accuracy's sake, but it is not taken in consideration for taking the reading. Okay, so whatever numbers are written, that will be the number of divisions on the vernier scale. So numbers written are starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this printed numbers, whatever is printed, so you can see there are 10 printed divisions. So the number of divisions on this vernier scale is what? It is 10, right? So this is how you have to check the number of divisions on the vernier scale. Now the vernier scale that I showed you a little while ago in my hand, that also has 10 divisions on the vernier scale. Okay, it also has 10 divisions, right? So it is similar to this one. Fine. So vernier scale is that it has 10 division. In some vernier scales you have 20 divisions. In some vernier calipers you have 50 divisions. Okay, so it depends. And when the number of divisions on the vernier scale increases, okay, the least count of the vernier caliper decreases, and the accuracy of the measurement that we take with those instruments also increases. So lesser the least count indicates that the smaller objects, can be measured accurately. Okay, so that is the connection. So least count is directly connected to how accurately you can take still smaller distances you can measure. Okay, so suppose if it is a 10 division vernier scale, then you can measure up to 0.1 millimeter. Okay, 0.1 millimeter is the least count. But if you take a vernier caliper which has 20 divisions on its vernier scale, then what happens? The least count comes down. Okay, it is not 0.1 millimeter, it is still lesser than that. And in that case, what it indicates is you can take even smaller than 1 millimeter, you can take even smaller distance and you can still measure it accurately. Okay, so in short, as the number of divisions on the vernier scale increases, the accuracy of your reading also increases. Okay, so that was fourth part of the vernier caliper. The fifth is something called a screw clamp. Okay, now this is something which is known as a screw clamp. Okay, can you see this? It's a screw knob. Okay, so once you keep some object between the two jaws, okay, then to take the reading, and then you remove the object, right? You just clamp it and then you remove it. So you have to tighten this screw. Okay, so this screw clamp is when it is tightened, then these jaws will not move easily. Okay, they will not move. And in the even after the object is removed, the jaws will remain in that position only, so that it will help you in taking the readings without any disturbance. Okay, so that is the purpose of the screw clamp. And the last part is the stem of the vernier caliper. That is this one. Can you see? This is the stem of the vernier caliper. Okay, the rod which is behind the vernier caliper. Okay, and this particular stem is attached to this jaw. Now see, this jaw is known as movable jaw because this can move, right? This can move right and left. But this jaw, this one is a fixed jaw. So you can name this as fixed jaw. It is not moving. And this one is your movable jaw. Okay, it can move. So this movable jaw, okay, is attached to this particular stem. So when you move the jaw, okay, the movable jaw, when it is moving, this rod, it will come out or it will get in the vernier caliper. Okay, so it is fixed to that movable jaw. Okay, and it helps you in measuring the depth, right? So these are the different parts of the vernier caliper that you should know. And now coming to how to take the measurement using a vernier caliper. So before we go into how to take the measurement of any object, okay, by a vernier caliper, you should know something called the least count of a vernier caliper. How to find out the least count of a vernier caliper. Okay, so next topic is how to find out the least count of a vernier caliper, right? So for that, we are going to assume a vernier caliper. So I'm starting from here. Okay, so let us assume a vernier caliper. VC is vernier caliper with vernier scale. VS is vernier scale having 10 divisions on it. So we are going to study how to find out the least count in this particular vernier caliper, in which the number of divisions on the vernier scale is 10. Okay, now normally, on the vernier caliper itself, the least count is always printed. Okay, for example, the vernier caliper I showed you in my hand. Okay, in that also, yeah, I want to show you once again. So I'll take you to the big screen again. Now, can you see somewhere over here, it is printed, right? Can you see 0.01 millimeter? Sorry, 0.1 millimeter. 1 second. No, 0.10 millimeter. Okay, can you see this? 0.10 millimeter. This is nothing but the least count of this particular vernier caliper, right? 0.10 millimeter, right? But then, you should know how you got that 0.10 millimeter. Okay, so I'll teach you that. Suppose it is 20 division, then the least count will not be 0.10, it will be something else. Okay, so let me teach you in general how to find out the least count. Okay, so fine. Now we are dealing with a vernier caliper which has 10 division on its vernier scale, right? So in that case, and this is the diagram. Can you see this diagram? This is the diagram. Normally first, what we have to do is we have to keep these two jaws. Now this is the movable jaw and this is the fixed jaw, right? F for fixed, M for movable. So first, without keeping any object between the jaws, you just make the two jaws meet together. Okay, just the two jaws, the movable and the fixed jaw, you make them stick each other, right? Exactly touching each other, nothing in between, so no object kept. That is the first step. So step 1, what I have done, when jaws are closed, this is known as closed position of the jaw without any object, when the object is not placed. So I have not taken any object in between the two jaws, and without any object I have just closed the two jaws. Okay, in that position, what can be happen, that I'm telling you. You have to first see whether the zero of the main scale. Now see, this is the main scale. Okay, I told you the different parts. So this is the main scale and this is the vernier scale. See, on this vernier scale you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 divisions are there. Okay, so these 10 divisions are on the vernier scale, and this is the main scale. On the main scale you can see this is 0, this is 1 centimeter, this is 2 centimeter, this is in centimeter, right? So this 1 centimeter is divided into 10 equal parts. So this will be 1 millimeter. So this is 1 millimeter, this is 2 millimeter, this is 3, 4, this is 5 mm. This is 5 millimeter. Then this is 6, 7, 8, 9 and this is 1. And this is 1.1 centimeter. You can call it 1.1 centimeter or 11 millimeter. You can call this 1.2 centimeter or 12 millimeter. You can call this as 1.3 centimeter or 13 millimeter, as you wish. In both the units you can take the reading. So this is the main scale, which is having some unit, but the vernier scale is not having any unit. It is just the division. So 0, 1, 2, 3, 4, just you have the markings. Okay, that doesn't mean that 0 and this distance between 0 and 1, the first division of the vernier scale, the distance is 1 millimeter. No, it's not saying you that. Okay, so there is no unit. It's only equal distance. You have 10 divisions marked on the vernier scale. Right, now what you have to do is, when the two jaws are closed without any object, just check whether the 0 of the vernier, that is this, and the 0 of the main scale, that is this, they are aligned or not. Just check that. Aligned means they lie along the same line, same vertical line. In this case, I can see that the 0 of the vernier and the 0 of the main scale are exactly aligned. Okay, they both are in the same straight line. So when this is the case, okay, we say that the zero error of the instrument is 0. So what is the zero error? This I will be explaining you later on. Okay, but there is something called zero error, which you have to check in the beginning only, whether you have a zero error or not. Okay, so in this case, when the two zeros are aligned, you say that there is no zero error, or you can say that the zero error is 0 itself. What I mean to say is, there can be a situation where in this position, when there's no object between the two jaws, and when the two jaws are just sticking to each other, it is closed, okay, without any object, it can happen that the vernier scale 0 will be on the left on the main scale 0, or maybe it will be slightly on the right of the main scale 0. That can happen. Okay, so if this situation arises, if the vernier scale 0 is either on the left or the right of the main scale 0, then we say that there is some 0 error. Then we cannot say that the 0 error is 0. Then we can say that there is some 0 error. Okay, then you will have to calculate what is that 0 error, and you will have to adjust that 0 error in the final reading. Okay, so this is, you have to check just before you start taking the reading, and that is why I told you about this 0. The concept of 0 error also I'll be explaining you, but first let me explain you the general measurement, how to take the measurement using a vernier caliper. So this is a vernier caliper which has 0 error as 0. Okay, so once that is checked, then you can proceed with taking the reading. Now suppose you want to take find out the diameter. Now this is, can you see, this is a ring, and the ring is placed between these two jaws, okay, of the vernier caliper, and this will give you something called external diameter, right? Now this ring also has internal diameter. Okay, it also has an internal diameter, but to find out the internal diameter, this same ring you will have to place it over here, okay, between these two jaws, because these two jaws are meant for finding the inner diameter. Okay, so if you want to find out the inner diameter, the ring you will have to place over here. But right now in this diagram, it is showing that the ring is placed in the lower jaws. Okay. And lower jaws are nothing but external jaws. So it will measure the external diameter. So this position may the ring is kept, the jaws are closed, and this screw, can you see this screw? This is that clamp screw. It is tightened. Okay. Once you tighten it, then you remove this particular object. Okay, you remove this particular object. No need of keeping the object over there. Just remove it. Because you have tightened this screw, this jaws will remain intact. It will not change its position. It will not move. Okay. So once that is done, now you can start taking the reading. Okay. So how to take the reading? So for taking the reading, first you will have to find out the least count of this instrument. As I told you, the least count is always printed, okay, on the vernier caliper. But I will teach you for theory purpose. I'm going to teach you how to find out the least count. So least count, how you are supposed to find out. Now see, the concept of least count is what? In this particular vernier caliper, the 10 vernier scale divisions, can you see this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 vernier scale divisions are kept in such a way attached to the main scale such that these 10 divisions are equivalent to this 9 divisions on the main scale, the first 9 divisions on the main scale. Okay. So you can say that the 10 vernier scale divisions are equal to this 9 main scale divisions, and 9 main scale divisions means 9 millimeter. See, each division is 1 millimeter, right? So this is 1, 2, 3, 4, 5, 6, 7, 8 and 9 millimeter. So in 9 millimeter distance, this 10 vernier scale divisions are kept. Okay. So can I write 9 millimeter is equal to 10 vernier scale divisions? Vernier scale divisions, they don't have units. Now I'm going to try to find out the unit of one vernier scale division. Okay. So 9 millimeter is equal to 10 vernier scale division. So one vernier scale division will be how much? Unitary method, mathematics. So one vernier scale division will be equal to 9 into 1, 9 divided by 10. So 9 divided by 10 is how much? 0.9. So one vernier scale division will be 0.9 millimeter. So now we came to know that this division, one vernier scale division is how much? It is 0.9 millimeter. Okay. So that is the first thing that you have to find out. Now, second is least count is equal to one main scale division minus one vernier scale division. This is the formula for least count. Okay. Now don't go into deep. Okay. Why this formula is like that, that you don't go, because this is very, very logical and you have to go deep and understand. But for your standard, for your level, you just remember that least count is given by a formula 1 MSD minus 1 VSD. Okay. Now why this formula is there, that you can understand in your higher classes when you come to 11th, 12th, your A grades or IB. Okay. So least count is equal to 1 MSD minus 1 VSD. Now 1 MSD is how much? 1 MSD means one main scale division. So one main scale division is just this much. Okay. And that is how much? 1 millimeter. So I'll write here 1 millimeter. Minus, how much is one vernier scale division? See, just now we calculated over here. One vernier scale division is 0.9 millimeter. So I'll write here 0.9 millimeter. Is that clear? So my least count will be 1 millimeter minus 0.9 millimeter, which works out to 0.1 millimeter. This is how you get the least count as 0.1 millimeter for vernier calipers which has 10 divisions on the vernier scale. Okay. Now there is another formula or another method also. Some books, they tell you that if you want to find out least count, use this particular formula. And that formula is least count is equal to smallest division on the main scale divided by the total number of divisions on the vernier scale. Even this formula works. Nothing wrong in this formula as well. So smallest division on the main scale is how much? So this is the main scale. And the smallest division will be, this is 1 centimeter. So this is half centimeter. And the smallest division is this one. Okay, so smallest division is 1 millimeter. So can I write 1 millimeter in the numerator? Divided by total division on the vernier scale. Now, how many divisions are there on the vernier scale? just the divisions, okay, not the unit. So total number of vernier divisions are 1, 2, 3, 4, 5, 6, 7, and 9, 10. So can I write 10 in the denominator? So 1 millimeter divided by 10 will be 0.1 mm. So here you are getting the least count. So either you find out least count by this way or you find out by this way. Okay, it's up to you. So we have come to the conclusion that the least count of this particular instrument, this particular vernier caliper, is 0.1 mm. Is that clear? Once the least count has been found out, okay, now as I told you, it is always printed on the vernier caliper. You need not take any pains to separately find out the least count, but just for the teaching purpose, I told you how to find out the least count. Okay, now once you know that the zero error is 0, once you know that the least count is 0.1 mm, now we can proceed with taking the reading. Okay, now this object was kept and it was removed also. And when you keep the object, what happens, this vernier scale, it has gone to the right. It has shifted to the right on the main scale. It is sliding on the main scale and it goes towards the right. Okay. So what happens when this is happening, the position now of the vernier scale and main scale will be different from this position. Now you won't see the 0 of the vernier in a straight line with the 0 of the main scale. No, now you won't see that. Now you will see that the 0 of the vernier has shifted somewhere on the right hand side and the main scale reading you will be seeing on the top. Okay. So to take the reading, what you have to do, you have to take the reading in 4 steps. Okay. Now what are the 4 steps I'll tell you. This is step number 1. Step number 1. Main scale reading. You have to find out main scale reading. What is main scale reading? See, I have written here. After keeping the object, okay, and fixing the clamp, okay, the reading on the main scale corresponding to the 0 of the vernier scale is nothing but the main scale reading. Okay. So here I'll show you. Okay. Can you see this 0 of this vernier? Okay. 0 of the vernier must be coinciding with some reading on the main scale. So what is that reading on which you can see this 0 aligning, 0 of the vernier? That reading on the main scale is your main scale reading. Okay. Now here it is very difficult to take the reading, okay, because it is not magnified. But here I have shown you a magnified image of one reading. Let us try to take this particular reading. Okay. So can you see this one is your main scale? Okay, this is main scale. This dark gray is your vernier scale, right? And now these are the jaws. This is your movable jaw and the fixed jaw is not in the picture right now because the object is kept. So movable jaw and the fixed jaw are at a distance apart. Okay. And this is the position. Now you have to take the reading. So what you have to do is for finding the main scale reading, first step I'm trying to explain you. Okay. This is that first step. Main scale reading. So to find the main scale reading, I will see the 0 of this vernier. See, this is the 0 of my vernier. Can you see? I'll circle it over here. Right? So 0 of the vernier scale is corresponding to what main scale reading? So this 0 of the vernier scale, can you see this 0? Okay. This 0, this line. Okay. Is corresponding to what reading? So let me check that reading on the main scale. So this is 0. This is 1 millimeter, this is 2 millimeter, this is 3 millimeter, this is 4 millimeter, this is 5, this is 6. And can you see this 0 of my vernier is between this 7 and 8, right? It is between 7 and 8, right? So what I can do is main scale reading, I can write as between 7 and 8. Okay, for the timing, I'll write between 7 and 8. See, if it is in between some two readings, you don't have the liberty of taking the lower reading or the upper reading or any intermediate reading. No, you cannot do that. Okay. If the 0 of the vernier scale is lying in between two divisions of the main scale, say it is possible that this 0 would have been on exactly the 7 millimeter marking. So in that case, you can write 7 millimeter. Okay. It was possible that this particular zero of the vernier scale would have been on the 8 millimeter marking. In that case, you write 8 millimeter. But if it is in between 7 and 8, okay, far you feel that it is near to 8 or near to 7, don't make any judgment. Okay, you have to take the lower reading. So if it is in between two readings, you have to take the lower reading. Now in this case, your zero is between 7 and 8 millimeter. So what I have to do is I have to take the lower reading, that is 7 millimeter. So my main scale reading is 7 millimeter. And this indicates that whatever object I have placed, that dimension is 7 millimeter and some more amount. Okay, because it was between 7 and 8. So right now we came to know it is 7 at least and something more than 7. Now, how much something more than 7, that we can find out using this vernier scale reading. Okay. So let us try to find out the vernier scale reading. So main scale reading you have understood how to find out. 7 millimeter is the vernier scale, main scale reading in this case. Now to find out the vernier scale reading, second step is you have to find out the vernier scale division. This will help you in finding the vernier scale reading, the third step. What is vernier scale division? First from the left, okay, first division on the vernier scale from the left that aligns with the main scale division, that you have to take. What is the meaning of this? As I told you, on the vernier scale there are 10 divisions. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first you check the 0 division. Is it in a straight line with the main scale division? No, it is not in the straight line, because we saw that the 0 of the vernier scale was in between the 7 and 8 millimeter marking. So it was not in a straight line. It was not aligned. So 0 is not aligned. Go to the next one, that is first division, okay, of the vernier scale. So vernier scale division, the first vernier scale division, even that is not aligned. I can see that this, can you see this one? This is the first division of the vernier scale. It is also lying in between. Okay, it is in fact lying in between 1.1 and 1.2. Okay, so it is not along a straight line. So first is not aligned, second is not aligned. Check the third one. Third is also not aligned. Check the fourth one. Fourth is also not aligned. Although it seems that it is very close to aligning. Okay, it would have aligned with 1.9 millimeter. Okay, but still I can see that the fourth division is slightly more than 1.9. Okay, fifth division, even that is not aligning. Okay, but the sixth division, can you see this sixth division? This is exactly in a straight line. It is in a straight line with the main scale reading. So this sixth division you have to take as your vernier scale division. Okay. So starting from the 0 division, then first, then second, and third, and fourth, you have to go from left to right, and you have to check which is the first division which is aligning with the main scale division. And in this case, it is the 6th division. Now, after the 6th division, 7, 8, 9, and 10, you need not see whether they are aligning or not. Okay. You don't have to check it. All the others will now be aligned or not. You don't have to check only. So you have to just check which is the first division that gets aligned first. So I saw that 1, 2, 3, 4, and 5 were not aligned, but the 6th was the division which got aligned. So 6th is the vernier scale division. Now third step is vernier scale reading. Vernier scale reading will be vernier scale division multiplied by least count. So what I got vernier scale division 6. That you multiply by least count. How much was least count? 0.1 mm. Right? It was 0.1 mm. So 6 into 0.1 is 0.6 mm. So this is your vernier scale reading. And your final reading that you can record will be main scale reading plus 1. This final reading is always main scale reading plus vernier scale reading. So main scale reading was how much? 7 mm plus how much was vernier scale reading? 0.6 mm. Okay. So when you add this two, you will get 7.6 mm. So this is your final reading. So whatever object you had kept here, it has a length of 7.6 mm. Is that clear? This is how you have to take the measurement on a vernier caliper. Okay. Now, today I want to wind up this session here only. Okay. In the next session, I will teach you what can happen if there is some zero error. This was the case where the zero error was nil. Okay. But I will now, in the next lecture, I'll explain you what is zero error. There are two types of zero error, positive and negative. And if there is a positive or a negative zero error, what you have to do and how you have to take the reading. That I'll be dealing with in the next lecture. And I'll be dealing with one numerical also on Vernier caliper. Okay, so that you get a better idea of this Vernier caliper concept. Okay, so today's session I'm going to wind up here only. In the next video, I will be coming up with the zero error concept and the numerical on this Vernier caliper. That's all for today. Bye. Take care, all of you.